So we'll record that to this computer. Welcome to IME 335. We're going to learn Mastercam today. So first time you've touched Mastercam, I actually just downloaded it an hour ago, 2025, and put it on my laptop. So it'll be the first time I'm using it on video live with you. It'll be great. So with that, we've got our CAD/CAM programming process. I tried to mention a little bit earlier that no matter which software you have, whether you got your Fusion, you got the same job, you got the same flow in terms of the things that you need to do in order to program a part. So in terms of CAD/CAM programming, there's really three major components out there. There's CAD, which is going to be the design. So the CAD portion of it has geometry. That geometry can come in a couple of different flavors. We can have wireframe, or we could have solid model geometry, right? So we'll talk about that as we go through. Within the CAD system, with the CAD part of it, you have some sort of geometry you need to cut. Then you have a WCS, or an origin that you've got to establish on the CAD geometry. So it's got to have a known location to that geometry. So that's really the CAD portion of it. The CAM portion of it is now the toolpaths. So with the toolpaths, you're going to be creating centerline location data. So as you know now, when we program to the center of the spindle. So you're going to be programming basically that location data, and it's got feed and speed, basically values, depths of cut. It basically sets up where that tool is going to go in the CAM. So we pick our toolpaths. And within those toolpaths, we've got our basically, I'm going to write F and S, that's the feeds and speeds. It's got all the variables for cutting within the CAM portion of it, right? Depths of cut, step over, finish passes, and so forth. Now, when it has that data in the computer, it doesn't actually have the G code yet. So the last part, or the third component of CAD/CAM programming, is the post-processor. The post-processor is nothing more than computer instructions that looks at the CAD and the CAM in the computer, and it writes the G code for you based off all of the inputs and outputs that you've set up in there. Does that make sense? So we're going to go along. We're going to bring in our design, or CAD, set our work coordinate system. Then we're going to create some tool paths. And then we'll end up post-processing and making code. Are we good? All right, no questions, huh? So we could program this thing completely with a wireframe model. In fact, I could program this entire part with just a 2D wireframe model looking at the top off the engineering drawing. So that engineering drawing I gave you, if I had just a DXF of this top profile right here, wireframe, all on one level, I could program this entire part if I knew my depths off the drawing. Right there. But the way back in my day, that's the way it worked. But with technology, we can bring in our SolidWorks model now, right? And program directly off of our model. And I'm going to show you how to do both, because there's times you need to use wireframe geometry or extract wireframe geometry from your model to make a toolpath work right, or to maybe constrain a toolpath, or to go ahead and drive a toolpath. Sound good? So realize we can use wireframe and surface models for CAD/CAM. Now, with that, this talks about the CAD/CAM programming process. I've already pretty much described it. How we have the CAD geometry with a home location. Then the CAM system puts out basically color line location data, right, with feed and speed values associated to it. And then you press the button and you get the code pretty quickly. Now, later on, we can talk about how we can modify post-processors and whatnot, but we're going to just use the generic default post-processor, or the mill one, and it works great on the Haas machines here. So that's going to be our experience here. So I'm going to basically take you through a step-by-step process to make this op1 of this part. Technically, you could flip it over, place it off, and have a part if you really wanted, or you could just keep it like it is. That's what I would do. So now, with that, does everybody understand that there's a drawing associated with that? That drawing's up on Canvas. So if you wanted this drawing right here, go to Canvas, download that PDF. I'm going to be using values off of it to set depths. I also have made it so you don't have to worry about feeds and speeds whatsoever. So if you want to cut this for fun, this is an actual thing, kind of like touch it off tools, right? you'd have tools 11, 12, 13, and 14. So we're staying out of the way. We're staying 11, 12, 13, and 14. It's like 1, 2, 3, 4, but I'll add 10 to it. Sound good? Now it gives you the surface speed and the chip loads for every tool. So it's not worrying about the feeds and speed. It's worrying about how to program. Cool. So I'm going to be getting all my feed and speed data right here. I'm going to ask you for these values. You hopefully will spit them out to me so I don't have to sit there and look at my drawing. Cool. All right. So I'm probably not coming back to this PowerPoint. The PowerPoint takes you through all the steps that I was going to show you. I might jump back to it once or twice to make sure I didn't forget anything. Sound good? But I'm pretty much going to Mastercam 2025 now. And let me move this up and out of the way because it's better up here than it is down here, because you're going to need to see some of these tabs down here. In fact, let's start off with that. I'm going to actually move this over here now. Now, what we've got is we've got our generic Mastercam right here. If you wanted to follow along on your computers, you can, or you could watch. It's up to you, and then try it out on the video. It's your call. But we've got 3 different tabs that we care about. This has way more than 3, doesn't it? In fact, it's got solids. I could solid model in here. Once you start to learn how it works, you're going to want a solid model in Fusion or SolidWorks. It's not the best for drawing and stuff like that. It's CAM software, basically. It's designed to program your machines. It does an amazing job at that. But it isn't really, you could go to solid model and you could build a solid model in here is what I'm getting at. In fact, if you saw there's a solids tab right there, I could do a cylinder, a block, extrude, but it's not as easy to use as, let's say, a SolidWorks. It's not as nice as a parametric feature-based modeling tool. It's like CAD from my day when I was in college, to be honest with you. So now, to get rid of that, does everybody see it under here under the views? They're called managers. In fact, I don't need art. I don't care about recent functions. I don't care about solids. I want 3 managers to program. 3 managers. I want tool paths. What do you think I create in there? There we go. They start listing out there. I'm going to do planes. Planes are where I set up my coordinate systems. Planes, you set up where you want your 0 point on the part. Then levels, that allows me to hide and show geometry at different levels. Kind of like if you did Larson for drawing, he would show you how to do levels for the dimensions on a different level. Make sense? So those 3 tabs are right there. It's underneath our managers right here. So it's underneath view. While we're in view, if you ever had to zoom or unzoom, they have like the zoom right there. But once you get a model in there, you're going to want to go ahead and just use your rollerball mouse to zoom in and out, most likely. I rarely ever go to like zoom here. But sometimes I lose stuff on the screen, like I zoomed way too far out or too far in. I can't find what I want. Fit is your friend. So that would fit it. Cool. Now, what's the first step of CAD/CAM programming? What do I need? I need geometry. So I can sit here and draw in here. What do you think we're going to do? We're going to import in a model. So to do that, we go File, Open. Whoa, right? We got this. And we're going to go to Computer, and we're going to go to Browse, and I'm going to go find, oh, the part's up on Canvas for you, SolidWorks part. Download it. So the part's up on there. It says Mastercam Demo 2024. It's a SolidWorks part. Right here where it's only looking for Mastercam files. Does everybody see that? So you click on this, and these are all the native files that Mastercam will open. It'll do Creo, if you're a Creo person. it'll do Rhino, SolidWorks, Solid Edge, Autodesk, Dassault. I was just looking to see if it had Fusion. You would save it as an IGES and bring it in, or another dummy solid. I don't think it does have like a native Fusion file. I was just curious. That wouldn't make sense, to be honest. It's not a good business model on that one. So what we've got here is we're going to go ahead and pick up SolidWorks, and I've got to go find where I saved mine. So I saved mine in my week 5 file folder, and it's called Mastercam Demo FA24. Again, like this is all on the fly. I just made this part up this morning. So makes it more fun for my day. So doing the same thing over and over. So I press open. Everybody got that? You doing good? Like, so literally I just opened my SolidWorks file. That's all I want you to know right now. And for some reason, I had these center lines because I just made a part and I mirrored some stuff this morning real quick. It saved this center line and that center line out of my model. I don't know why. I've never seen it import center lines before, but go ahead. I'm going to press Control Z to show you that. And that's your friend. Control Z, it undoes something, right? Command Z on the Mac. So we'll go ahead and click on that. And we'll click right there. And also, I don't need these center points for right now. I'm just going to click on them to delete them. It puts center points for the circles, little center marks. So I have my model in here. How's everybody doing? You got any questions? So I have a model. So the first step to CAD/CAM programming, import your geometry somehow, wireframe, solid, whatever you need. Does that sound good? Now, the second thing, what do I have to set now? Anybody? Work coordinate system. Bless you, by the way. So we've got planes for that. Now, if you had design intent, I thought I did, and I realized SolidWorks and Mastercam are like 90 degrees off the planes. So I'm not going to make the joke. So we've got, I got a good one. So that corner is where we want it, right? I specified in our drawing, if you look, G54 Z0 set at bottom of stock, top of parallels. So we want it down here, right? Because it's going to sit on the parallels. Now, also the XY upper left corner of stock. So that's upper when it's sitting in the machine, and left is this side, right? What's the problem with this way it's set right now? Yeah, so right-hand rule, the Z needs to be pointing up where your tools are located, right? So I need the Z pointing up where the Y is. Now, I could do a couple of things. There's old school way of doing it and the new school way. I'm going to show you both, just because. So you can't change the world in terms of CAD and geometry. So what you've got right here is you've got 6 views. You cannot change the way those views are oriented. Does that make sense? But I could take one and duplicate it and transform it. Or I could use the button that's dynamic, the new way, the cool way, and do dynamic. So I'm going to show you the old way that's kind of more confusing. Then I'm going to show you the new way, the dynamic way. Sound good? That way you learn a little bit of both. So does everybody see this little plus right here? Dynamic is where you would want to do it. We're not going to do that real quick. We're going to go ahead and we're going to see that this top view is kind of what we wanted. I could right click, I could duplicate it. When I duplicate it, it allows me, I'm going to write old way. Sound good? It allows me now to shift it or rotate it. I can't rotate the top view off of the, because it's the top view. You can't switch the top view, right? But if I duplicate it, I can now right click on it and rotate incrementally around the x-axis. If I rotated 90 about, negative 90 about the x, positive, or 270, right? It's negative 90 or 270. So that would be check mark. One way of doing it, one way of setting a home location. You pick one of them that you want, and check this out. If you didn't want it right there, I click this button, I can move it anywhere now. I just got to get it oriented, and now I can move it wherever I want. You see that? Where does it go? Right there. So if you knew how much you wanted to shift it mathematically, you could just put the XYZ right here from where it currently is, or you could hit this button and go select it where you want it. That's kind of the old way. There's a lot more button presses. You want to see the new way? So the new way, it's dynamic. So you hit dynamic. It gives you this really cool little, basically Cartesian coordinate system. You pick where you want the 0 point. Now, if I wanted to shift it 90, I could do that and type in negative 90 tab. And it's where I wanted it. So that's their newer way of doing it. I don't know. I guess they're both great. How about that? So now, does everybody see though, before you would hit check mark, you could see in here, you could move it around other places. But does everybody see where you have it has the name? What do you think I'm going to put in there? I'm going to write, yeah, G54 WCS. Cool. So when I hit check mark, it puts it in the same, it's the same thing, right? Old way and what I just did right there are the same exact thing. You've got to have a 0 point at the bottom, wherever your fixed location is in your machine. Is everybody good with that so far? Are there any questions on what I did? All I did was set a home location. So if I went back to basically right here, set your work coordinate system G54. You can kind of see it in the plane manager. Now, in order to use it, I have to select it. So my program will not make that my work coordinate system unless I make this say WCS right here. So I do that two ways. I could go ahead and click on the E right there, WCS, CNT. Or at any time I can hit this equal button and it sets that as my home location. Yes. That's check marks the active, kind of the active one there. So when I when I go equal, fair enough. There it goes. So I made it equal. That's the one that's kind of, it's like, hey, we're using that one. Yes.
What's CNT?
So that's a great question. So C is your construction plane. So when you're constructing geometry, you can only do it on planes in a 2D environment here. So back in the day on CAD, you'd construct on the top, the right, or the front plane. And then you make it go out 3D out into space like that. So we're going to use construction planes later on. Don't worry about them right now. T is tooling plane. When I got to index something in a multi-axis, like a rotary, and I wanted it to rotate maybe 30 degrees, I could point the Z and basically at a view like that and get the Z to point normal to where I want it to rotate, and it would rotate the axes that way. That's advanced. We're going to do T planes later in 336. Cool. But yeah, so C for right now, make WCS, C, and T match, and you will have no issues. It's later on we start to switch them up when we do advanced multi-axis stuff. Now, so I've got my work coordinate system set. Are there any questions on that? Now you don't have to do this part. I want to show you how you could do wireframe and solids on different levels. So I wouldn't probably follow along with me on this part. Sound good? Unless you want to. So when I go to another level, oh yeah, look, it's got some hidden entities. So let's see what the hidden entities are real quick. So it created a lot of different little pieces right there, right? For wireframe when I brought it in. I just want to show you though, real quick, I could create level number 2 by just typing in 2, and I could call this wireframe. So right now it's got 0 entities on it. If I make my solid, you can hide the levels. You see that? The one with the check mark cannot be hidden because it's your active level. So the one with the check mark is where you're making geometry. So if I wanted to make this into wireframe by itself, I could go to wireframe, curve on all edges, drag a box around the entire model to select the entire model, hit end, check. And now if I was to hide the solid model, check that out. There's all the wireframe for that entire part. Does that make sense? So there's sometimes you might just want to extract a piece of geometry off your model and make it wireframe. So that's what this is for right here. If I want to press Control Z, it undoes it. There's no wireframe entities. Like let's say I wanted to go curve on all edges and I just picked that top surface. I hit in selection, check. I basically now just have that curve in space if I needed it. A lot of the times you need to extract some geometry out to drive your cutters. We doing all right? So you don't need to do that to program this whatsoever. I'm just showing you that there's wireframe geometry and solid model geometry out there. So what I'm going to do is press Control Z and just show the solid model geometry. I didn't even need that level. I just wanted to show you how that worked. So if I go back to the PowerPoint, it shows, or it talks about, pretty much shows, I have to talk about it, the wireframe versus solid model. You see that? So I could program this off of either one of those. Oops. So we set the G54. We talked about the tool plane and the construction plane. Now let's go pick a post processor. Sound good, everybody? So even though post processor is the third component, we got to know what type of machine tool we're programming off of when we start programming. Because if it's a lathe or if it's a mill, I don't need lathe tool paths or vice versa. Make sense? So that's going to be under machine, everybody. If you click on machine, there's the mill. And underneath mill, you probably have nothing like, let me go back to what you have. So when you go to mill, does everybody see how there's nothing under there? It says manage list. Let's go manage the list of our post processors. We only have one, a mill post processor for now. The PowerPoint shows like 10 because it's off my computer with like Haas and other stuff. So just, this is the right way, with just two. What do you think MM is? You're in engineering. We have MM. Very good. It's millimeters. Thank you. So are we going to pick the MM one? No, not unless we had a metric machine set up in metric. So we are going to pick this one. And all you got to do is you have to add it the first time. So if I add and I press check mark, now whenever I pick mill, does everybody see the default mill post is right there? So that's going to be the post processor we're going to use. Later on, you can get specific post processors for specific types of machines. The generic mill works great on this Haas machine. Fair enough? Cool. So guess what I'm going to select for my post? Mill. Now, where do you think that showed up? Over here in the tool paths. Does everybody see that? So this wasn't here. This was blank before I picked a post processor. So now this machine group is my mill group. If I open it up, you can see it says mill default. If you wanted to get into post processor editing and everything, it's in these files in here. Don't worry about that. But if you're interested. So what I've got here is I've got this group. I'm going to rename it to mill op number 1. So I can simply right click, go to groups and rename that group just so it makes sense. Mill op 1. Sound good? Now, if I had 5 operations in here, I would just do that 5 different times with whatever machines I have. Maybe it goes to mill, maybe it goes to a lathe on the same part. You can do that. We doing all right? This is making sense? Cool. So after we have a post, before I create any tool paths, I need to show this thing some virtual stock just for simulation. Sorry about that. So I'm not going to interrupt him. So with this stock setup, it'll be on the video too. Let me show you that. It's right underneath the post. I'm going to exit. It's right underneath the post processor. It's called stock setup. You click on that and we could, if we had a casting, we could show it a model of our stock. So we don't cut too much, right? It kind of needs to know where that stock is located. So what I'm going to do is I'm going to pick, is it rectangular stock, round stock? What do you think? Bounding box? I could pick 2 corner points and builds a stock in 3D. What do you think is the easiest? Rectangle right here. And you click on your part. You hit in selection. It builds it around your part. But is that right? No, because look at the 990. Did I buy 990 stock? What do you think I bought? 1 inch. We're just going to face a little 10 thou off the top. Sound good? So where do I fix that, do you think? This 495 right here, or this 990 right here will work fine. 1.0. Also, I want to be in this bottom left corner. Hold on. And I want to be, I messed that up. I want to be on my G54 work coordinate system. Hold on. Off that corner. And I want 0, 0, 0 up here. I messed that up. I'm going to press X and show you it from default. Because check this out. So stock setup. I want to pick my plane first. So now the coordinates don't get messed up. So my plane that I'm working off is G54. Does that make sense? I had top selected, so when I clicked the button, all my numbers were off the top and they were completely backwards. And so I didn't feel like doing the math for you at the beginning. You could do it, but so now when I hit rectangle, I hit that and I hit in selection. This makes a lot more sense if I do 0, 0, 0 right there. It doesn't shift from the origin is the problem that I had before. I had some numbers in there. And my origin's the back left corner. You see that? It's not the front left, it's the back left. And my stock height is 1.0. We doing good? Oh, sorry, I'll get it.
It's okay.
Sorry about that.
No, it's okay.
right.
You just need a tool.
Yeah, it's your tool. Cool. So does anybody have any questions on the setup right here? Really? So the idea is that stock plane has got to be G54. We give it the 4, the 1 1/4, and the 1. Then it's off 0, 0, 0 if we go off this back left edge. Fair enough? Yes.
I have the G54 selected, and so like it's populating the stock underneath the part. Is that
It might be where you have these like up here. Maybe click your button, click these radio buttons so it just matches up to the part and you'll be good. So when I hit check mark, I got to be able to show that stock somehow. What do you see up here? Display, you see that? And I could shade it. So that's all the material around this part. What questions do you have? So we've got geometry, WCS. Part of that, I'm just going to write down here, we add virtual stock. Actually, that's more in CAM, right? Stock and sim. You have virtual stock and we can simulate in CAM. So let me jump back to the PowerPoint. We have our virtual stock, and that's where basically the pictures are different now from the old part, but it's going to be the same process. So what toolpaths do you think I need to do in order to plan this, everybody? I want to hear it from you. What do you think I'm going to do first? Face mill, that's a good idea. So we're going to face it to the right height. What do you think we're going to do second? There can be multiple right answers. We could drill. We could contour. Yeah. So when you say end mill, we could contour the outside, right? Where else do we have to contour? The inside, right? We'll contour the inside. Yeah, so we'll contour on the outside, we'll pocket on the inside. Then we're going to do maybe a bore to make a hole. Sound good? And then when we have a hole that's small enough for a drill, what do we use? A drill bit. We're going to drill. And so we don't cut ourselves on this widget. What should we do last? Chamfer. So that's basically what we're going to do. We're not going to spot drill the thing. We're just going to drill. We're going to let it walk. There's no tolerance on the thing. So it's a demo part. So I'm ready to create tool paths with you. Do you see? So we have mill op 1 here. Does everybody see when I pick this machine, this mill machine, I got a brand new tab called tool paths. What type of tool paths, you ask? Mill ones, because you picked a mill post processor. You get lathe ones when you pick the lathe post processor. You doing good? We'll do lathe after this one, like in 3 weeks. So my first tool path, let me come over here, is going to be face. So what I'm going to do is I'm going to pick my face. Now, technically, I don't have a rectangle on the top of the part, but I got a rectangle that shows my stock size. Does everybody see that? So what I'm going to do is I'm going to pick the rectangle on the bottom of the part. So to do that, I'm going to pick that one right there. So you got to play around with this, just to let you know. So there's different ways to select things. There's edges where if I pick an edge, I could work myself all the way around, but that would take a long time, right? So like sitting there and I could hit that one, or I could basically hit that one right there just to continue it going. That's what I want, but that was a lot of button presses. So there's this one right here. But what happens when I click on that face? What does it include? The circle that I don't want, right? So there's this other one over here. Click off it, you hit the little red X. That'll just do the outside if you don't pick the entire face. See, so it loops the entire outside. Then I'm going to press X again. And what I'm going to do at this point is show you the partial. So the partial will also loop it. So there's many different ways. You just got to play around with it. Cool. At this point, I'm happy with my selection. So I'm going to hit the check mark. And this is the classic Mastercam window that you're going to see for most of your tool paths. So this is how you build your entire tool path right here. This window with all these parameters. In fact, this first window right here, the tool path type, we've already selected everything in here. It's there in case you needed to change it. So I already picked facing, right? I already picked the geometry. I can click the button. It shows me my geometry. I hit check mark. If I hit this, it would delete my geometry. It'd be bad. So that's pretty much what this menu does. Now, the next menu is how you build your tool. Fair enough? So what you're going to do is you're going to come over here and you're going to right click and you're going to create a brand new tool out there. So I'm going to get the tool library out. And what you could do is you could go off of their tool library. They have this tool library that pretty much has all the different tools set up. In fact, let me go ahead and go to my filter. So I've got end mills, ball end mills, bull end mills, pretty much any type of tool you could think of. I could do it that way. Or what you could do is you could actually just create a brand new tool if you wanted to. So you could create tool. I want you to create tool. Fair enough? Because I want you to get the experience of just creating the tool from scratch, not using what they already have, what the interns put in the tool library during the summer, stuff like that. That's a good intern job, right? So what we've got here is the first tool is going to be a face mill. So I hit next. It's cutting diameters 2. Don't worry, it'll be fine here. It's got 0 chamfer. Fair enough. That's all it needs. So your length of cut is right there. 0.2 is about all that thing could do. And then your diameter is right there. It builds a dummy tool. And when you're done building the dummy tool here, kind of like the diameter is what matters. You go to next to fill out the feeds and speeds. So this is actually tool number 11, right? So I'm going to go ahead and type in tool 11. And if I remember right, I did 3250 surface speed and 6 thou chip load, right? It's a 2-inch face mill. Is everybody doing good? Now, if you wanted to, does everybody see in this milling, it's got the rough XY step over percentage? You can fill all that out and then it would default put that into your menus in Mastercam. I just go through and change them. I never really do that. But you can do that, the default percentages. For now, we're going to be good. What do we do? What does Treon do, you think, when he gets 148.992? I like round it up. 150 is right. And so like plunge rate is more like 75, right? We're going to half. And retract rate, if we're in 5% rapid, 500 retract, it won't retract. It won't wrap. It'll go up fast. Sound good? So when I hit finish, I now have a tool. Does everybody see it? I built one tool. We're going to build 3 more. Cool. Now the holder matters really if you're doing multi-axis and you're worried about collision on your holder. So I always pick the funny ones for my demo like that. That's real rigid, right? It's supposed to be a joke, but yeah. So I'm just going to pick that holder. You don't have to pick a holder whatsoever. It's just part of the simulation. Cool. So I'm done with holders. I'm not going to talk about them anymore on any of the other tools. Now, cut parameters matters. So I could go zigzag both ways, climb and conventional, zigzag. I could go one way, climb or conventional. I pick. I could go one pass. That probably makes sense for this one. Because it's one pass right down the middle. It's a 2-inch part, 1 1/4 inch wide, or 1 1/4 inch wide part, 2-inch face mill right down the middle, right? Or I can do dynamic, way cool. We're going to learn about it though in lecture before we use it. Sound good? So we're going to learn about how dynamic gets constant chip thickness next week in lecture after the midterm. So for now, we're going to go one pass. Now, these are the default like step overs and like lead in distance and exit distance. They're usually pretty good unless you got to get around something. So I'm going to leave these values the same. Would I want to leave 50 thou on the floor? No, I don't even have 50 thou to take off. I'd leave 0. It'll leave whatever extra you want there if we don't need that. So that's all I do there. Cut parameters, I'm good. If this was a big depth of cut, like I've had to take off 1 inch with this face mill, I would click depths of cut and tell it what the max depth of cut is. And then how many finishing passes I want. This is my finish pass. We're just taking 10. Am I making sense? Cool. Linking parameters are going to basically be where your tool goes. There's something versus absolute versus incremental here. Incremental is off of your geometry. Absolute is off of basically the world, off of this XYZ 0. It just so happens that incremental and absolute are the same exact location in this example right now because I picked it at the bottom of the stock, right? So I'm going to pick absolute. This is a new menu. It's nice. It's got some pretty graphics. Didn't used to look like this. It used to have that end mill is newer and then the little lines showing where things are. So check this out. What I do is I'm going to do absolute. What would absolute retract of 0.25 give me? An end mill through my part. So I would want to be 1.1 retract absolute. Make sense? My feed plane is 1.1. My top of my stock is 1. Let's say you're bad at math and didn't know how deep to go because you didn't have the drawing in front of you because you didn't make a drawing. You go ahead and you click the depth button. You come down here and you zoom in. Don't accidentally grab the chamfer line, the bottom one. It's that one up there. It should have put that value in. I don't think I grabbed that. There it is. It's got to turn yellow, 0.99. Everybody see that? So at any point, you can go out here and click using these out in the window on your geometry. But I usually just give it the exact numbers that I have. But this is the most important menu, I'd say, because it sets all your rapid heights. It sets your final depth and everything, the linking parameters. Is everybody good? That's it. So I'm going to make this toolpath. But before I make it, by default, they have the coolant off. So if you go to coolant, turn it on. So at that point, I hit check mark. I'll make a noise. Bzzz, it just machined off the top. And we have one pass along the top of the stock. Everybody good? I did one pass right through the center. I thought it made most sense. You're going to learn why that's bad later. So there's got to be a way I can check to see virtually if this looks good, right? It's called simulation. There's 2 ways to simulate in Mastercam. There is backplot. By me clicking on backplot brings in that sweet holder, right? And I press play. I'm going to go faster. There's a little speed right here. It's real touchy though. See that? So that was it. Or there's this verify right next to it. I hit verify. It's going to show me this really cool 3D window. I can press play. Oh, that's it. It made it 10 thou shorter. I think we're good, right? And it did that in 4.4 seconds. Pretty cool, right? So I close the verify. What questions do you have so far? We're going to do the same thing over and over and over now for the rest of the toolpaths. And then we're going to look at it. Now, what we've got here is we've got a blue line in the way. Do you see that? There's got to be a way to hide those, right? Does everybody see the wavy blue lines next to the ghost? The wavy blue lines hide and show tool paths. Makes sense, right? The tool paths are blue lines. It's got 3 blue lines. So you can hide. Whoops, don't ghost things. Hide and show. I'll talk about ghosts later. It's like suppressing. Ghost is a suppress, basically. They just, yeah, they had ghost before suppress was around. This has been around since 1983, software. So next, let's go ahead and contour the outside. Sound good? So I'm going to contour the outside. Maybe does the stock bother you? You could just not display the stock if you didn't want to. You can go back and forth. I'm going to take it off because it bothers me. So now next, if I'm going to contour around the outside, what toolpath do you think I'm going to pick? Contour. So there's other ones. There's more advanced stuff. We're just going to pick the basics for today. Today's like your first day. It's already a fire hose in the face. You're probably like, oh my God. So, but we're going to be good. We got videos. We're going to learn how this works. So check this out. I'm going to pick loop. I could pick the loop down here, or I could pick the loop up. Not that one, because that's a chamfer. Or I could pick the loop. No, it's not going to do it with that one. It'll do it with, it would do it with. I'd have to pick, I'd have to pick it individually to go at the top. So the best answer is this one down here, right? This loop. Does that make sense, everybody? So now that I picked it, when I hit check mark, look at that, the same menu pops up that we're going to be using. So this time, instead of facing, it already has contour selected. See that? Now, with contour, if I wanted to see my geometry, I could click that button again. And when I look at my geometry, I already have a problem. Does anybody know what it is? It has to do with arrows. It's into the part. Where should it be? Yeah, so you can flip. The arrows tell you 2 things. Direction of milling. Side of the part that it's going to contour on. Direction, and they're both wrong, aren't they? You know why? We want to climb mill on the outside. So let's go ahead. You could easily right click on them and basically reverse. Oops, change side too. There's 2 things. There's change side and there's reverse. So now when I hit check mark, that's something you should always do after a contour is just double check you got your arrow on the right side. If you don't, it drops it on the other side. You just go back and swap it. Yes. Because we want to contour the outside of the stock, not the inside of the stock. Sound good? Cool. So now that I've got my geometry down, what's next? The tool. So the tool, we're going to do it together. Create tool. It's an end mill. By the way, they already got tools built, but I'm showing you how to do it from scratch. So it's an end mill next. It's 0.375, I believe, right? That's tool 12. Its length of cut, I think, is 1 inch actually. And when I go to next, it's tool 12. Its surface speed, I think I put 750. Is that right? Yep. 750, which gives me 7,600 RPM. It's got 3 flutes or 3 teeth. And the chip load was at 3 thou or 2 thou? 2 thou chip load. I'm going real light just in case it's your first cam. So what does Treon do when he sees 45.8? 46. This far in a minute is not going to break your tool. So 10 inches in a minute probably won't. Well, in aluminum it won't. So plunge, I'm going to just do 24. I like even numbers. You'll see that. So basically what I did there is I set up my 3/8 inch end mill with the right feeds and speeds. I hit finish. So one I'm going to use, right, the 375. One thing I didn't show you down here is you can modify the feeds and speeds right here. So whatever's in the library, it shows up by default. You can modify them right here. If you modify them, you can right click on them and reinitialize them from the library if you had to. Now, I always click rapid retract, but the retract's probably faster than the 5% rapid here. It's up to you. But I would always, just for now, hit rapid retract so it pulls out G00 and Z whatever it does to the clearance height. Cool. That's one thing I didn't click on the last toolpath. I forgot to tell you about that. Now, so the second tab is all about the tool, right? The feeds and the speeds. The first tab was all about the geometry and the type of toolpath. The third tab is the holder. Do we care? That one looks great. So we're good for now. We don't care about the holders. We do care about cut parameters though, right? Do you remember when I talked about cutter compensation? Back in the day, like 3 weeks ago, 2 weeks ago. Well, there it is right there. We got computer, we got control, we got wear, we got reverse wear. Don't use that one. And we got off. So we're going to just run with computer for now. It's going to basically do the same thing you did in your first project. Knows the exact diameter, 375, and offsets it at 0.1875. So, it doesn't post to cutter comp. If our cutters are sharpened, our parts are coming out big. But we're learning about CAM today. Sound good? So we're going to run computer cutter comp for now. We're going to compensate to the left of the line to climb mill. Right? And roll around corners, just do that. Just for now, I'm going to talk about that later. But when you have a sharp corner, it doesn't do this. It rolls it. So it rolls it on the tangent edge, so it stays on the gas when it's going. It doesn't fully stop and go. You want to roll around sharp corners. We don't have any, though, to show you that. So at this point, if this was a roughing pass and I was going to come back to finish, I could leave material on the walls or the floor. But we're just going to rough and finish this in one. Sound good? So we're not going to leave any stock. Should we do depths of cut on a 3/4 inch depth and a 3/8 end mill? We'll do that. We'll basically do it we'll do it in 3. We'll go 1/4 inch depths of cut. We don't want any finishing passes. This is on the floor. Does everybody understand this depth of cut is the floor for the finishing pass? It all makes sense if you sit there and look at what it says. It usually does. Do we want lead in and lead outs? Yeah, good idea. It puts extremely large ones into it. I'm going to leave the extremely large ones in for right now. I'll make them smaller with our other project. Sound good? But it's doing like a 375 length and a 375 arc into the thing there. I mean, that's giant. Hold on. I'm going to make them 1/8 inch. And then I'm going to use this little arrow to make this one match that one. These arrows will transfer the data from one to the other so they match. Now, before I'm all done, I want to do one rough pass. And basically, I want to go ahead and do one 10th finish pass. I'll talk louder, I guess. So 10th there. I'm going to finish only on the final depth. Does that make sense? So it just finishes one. So now the last tab is the most important one, right? It's going to be our linking here. So our depth, I'm going to do all absolute. I'm going to introduce incremental on our next project. So we're going to go absolute. We're going to do 1.1. Actually 1.1. We're going to feed at 1.1. The top of the stock is now not at 1. What is it at? 990, right? And the depth, absolute. Let's just say I didn't know this was 140 thou down here. It probably isn't actually. Forgot the number. Having a hard time selecting that. There it goes. It's 0.24. Yeah, it's 0.24 thick. Go to your coolant, turn on the coolant. Once you do it one time, it'll be on for the rest of the toolpaths. And you hit check mark. What that does, everybody see it, it roughs twice, a rough's 3 steps down, then the last pass it is a full depth of cut, full flute, finishing it. You won't see any lines in the thing. How's that work for you, everybody? Yes. So what we've got right here is depths of cut is the floor. So this finished pass right here would be an extra one on the floor. Don't need that because the floor isn't part of the part. So this one right here, multi-passes, when I turn that on, does a rough and a finish then on the walls. So this is all the walls. Does that answer your question? Perfect. So now, what else do I need to do? While this end mill's out, should I continue to use it or should I swap it and bring it back out later? Use it, right? So what I'm going to do is I'm going to show you a pocket tool path now. Make a pocket in the part. So when I go to that, which one am I going to pick? Thank you. So with pocket, I zoom in. This one, so at this point, I'm going to do basically a partial loop. Actually, no, I'm going to do a single right there. If you wanted to go a different way, you would click on the blue arrows. If I want to continue that way, you just come right over here and go to next and work it around. Way easier, right? This will also allow you to adjust your direction. See that? But I hit check mark. The pocket is closed geometry. It doesn't care about an arrow. It knows that it's inside the closed geometry, the pocket. It will have an arrow. No, it doesn't actually. It has an arrow just for the direction of feeding. So when I go to tool, did anything change in my tool? Yeah, no. What happened to it between the two operations? Nothing, right? So it's going to run the same feeds and speeds. So I don't do anything here. Did the holder change somehow magically? No. The cut parameters, though, make a difference here. For this pocket, am I going to leave any stock? I'm going to rough and finish it all in one. I didn't tell you that, but we're just going to rough it and finish it. So 0. I'm going to roll around all corners. Oh, we should just pick that for now. There's no reason really not to. We'll talk about it later. When I rough, I'm going to rough with my high speed. You can pick your kind of your logarithm basically, or your strategy on how you're going to go ahead and open up the pocket. I'm just going to run high speed. I'm going to step over at like 40%. And that's all I want to do right there. Now, by default, it's going to want to come straight down into a pocket. What do we do into pockets? Louder. Helix. Yeah, we're going to helix. I rode dirt bikes all yesterday. I can't hear. So we got entry motion. We got helix. We got minimum and maximum radius. I'm good with that. I like to change my plunge angle to 2 so I can go a little faster. But I do hit plunge rate instead of feed rate on my helix. That can get you sometimes. You're like, oh, it's going fast. So I can either do a clockwise or a counterclockwise helix. We'll just do a clockwise. Sound good? And we're good there. Now, if I wanted to finish the walls, right here, I could do a 10 thou finish pass on the wall. And that would be my lead in and my lead out. I would just give it like 100 thou. Lead in, lead out. It's really small values. And if I wanted to finish the floor, I could do 1 finish pass on the floor. My rough step would be my full pocket depth, and then 1 10 thou finish pass will come back and clean up the floor and clean up the walls. Does that make sense?
Are those the same sorts doing floor?
It'll do the floor, and then the last one it does the wall. Now on linking parameters, we're going to change everything to absolute just for today. We'll go to incremental next lesson. And we know that 1.1 is above the part easily. So both the feed and the retract should be above the part. It's kind of like where it feeds down to, it's your G00 is where it starts and where it pulls back up to. That's what I did in manual programming. Now your top of the stock is 0.99. The depth, let's say I didn't know it was a 1/4 inch. I click on this button, I click on the bottom, and it tells me it's 0.74. Fair enough. So coolant isn't on this toolpath, so we press on. We hit check mark. And here we go. So this end mill isn't big enough to fit in this little area right here. So let me go back to this. Parameters. We'll get this fixed. So I don't leave anything right there. We're going to, let me just look at the step over distance. We are probably just going to pick a smaller. So does everybody see how I didn't do a helix either? It's because it can't with the size of parameter that we gave it. So now it can do a helix down in, but do you see how it doesn't link in between? The cutter is just too big to do that. So let's switch it to a 1/4 inch. Sound good? I'll basically make that. We're now going to have a tool basically 13. Sound good? We're just going to go up, and I'll change all the documentation. Or should we make it a 15? Your call. Let's make it a 15. Sound good? So to fix that, all we got to come over here. We got to go to tool, right click. We're going to create another tool, an end mill. It's going to be 1/4 inch in diameter. It's going to be tool number 15. It's going to be a 3 flute. Now watch this. It's such a small diameter, like a 650 surface speed will be like almost 10,000 RPM. You see that? So we're going to run 650 surface speed at a 2 thou chip load. So 60 inches a minute. We'll 30 plunge. Fair enough. I'll update the document. I'm going to fix all the documentation in this lab. So we'll go with that smaller tool, check mark. Now, what it was able to do, it was able to go in there rough and then come out right there, right? And do the finish pass through. Is everybody good with that? There's a better way to do it with some dynamic, but I'm not worried. We're not learning dynamic until week 2. So any questions? Now let's go ahead. Let's come in here. Let's hit the check mark. Let's go ahead and let's go down to slow and press play. Well, that was way too fast. Look at that. It still leaves, if you see that, it's going to leave that. You see that? It's a weird pocketing routine. Give me a second. That is so weird that it. Quarter inch diameter. There we go. I changed the routine. It was having a hard time, but that true spiral is going to go ahead now and just spiral itself out. So we come back over here and we go to simulate. Sometimes you just saw it. Sometimes some of the pocketing paths don't lend themselves well to clearing out the geometry correct. So anybody got any questions so far? No? All right. So the next step, we're just going to bore this I think it's a 7/8 hole out with a 1/4 inch end mill. Now to do that, all these tool paths are in my way. So if I go ahead and I click on the blue lines, they disappear, right? See that? So let me press save too. You never know what could happen. I haven't saved it at all. Trust me, you should save often with this. You'll be bummed if you worked for an hour and have to start over. So with that, we're going to go up in here. And does everybody see? Well, we got circle mill circular pockets, or we got helical bore. So they're both about the same. So I'm just going to do a bore. Right there's the center of my bore, right? So all we're doing at that point is picking the center and hitting check mark. And that brings in my part right here. So if I got my tool, I'm just going to use the 1/4 inch end mill to make this bore. I'm going to use the same holder. It's got stock. I'm not worried about that. I want my cut parameters here. We're not going to leave anything on the walls or the floors. Right there. You've got the rough pitch is 0.08. Let's see here. I'll do 50 thou instead of 80 thou. And then let me just go back up to the top. Let me just delete this one real quick. Pick in the bottom. There we go. Now, last but not least, we're going to pick our retracts at one. Everything's going to be absolute 1.1. Top of the stock is at 0.99. No, it isn't. It's at 0.74, right? So we just pocket that out. And the depth comes down to, I forget, I think it's 0.24. Basically there. Yep, 0.24. And feed rate at final depth. That's good. Number of rough passes. So we're going to have to do 3 rough passes, I believe, maybe 4. One step over. Cool. So when I hit check mark, we got our bore. That's bigger, actually. See where it's at the edge? Hold on. Why did I grab? Tool access control. Somewhere. I don't have my cutter comp on.
Side.
Did it pick the outside curve? You're probably right. Oh yeah, diameter 1.05. There it is. Oh, that's gonna be in the center. I need to select. Do you know what I do when I need this? Hold on. Check mark, check mark. It's broken, but what can I do real quick? Watch, I could go. This is gonna be a good example for this, right? Wireframe, it's active. I can go to wireframe, curve on one edge, boom, check mark. So now I have that curve, right? And then go back here, that. So it wasn't able, so you're seeing why sometimes you need to have wireframe, right? Because I was having a hard time grabbing just that circle down there at that point. So when I hit check mark, now we're good with the bore. Is everybody good with that? I could have used the bigger tool, but I just had this one out. So the question is, why don't you use the bigger tool? So check this. We might as well answer questions as go because this is 100% on the fly. I'm going to take this pocket tool path. I'm going to drag it down here, move after. I'm going to come up to here. I'm going to go to tool, and I'm going to use the bigger tool for that bore because that makes more sense. Does that make sense? It makes way more sense to use the bigger tool. So if you're programming along, that was pretty easy to do, right? Just you can right click on them. Actually, you can drag them, and then it says move after, move before, or cancel. So that's how you reorder stuff. Now, what else do I need to do to make this part? I got 2 more tool paths, I think. It doesn't though, because we already pocketed all that out. Oh yeah. Very good. You're right. I didn't even think about that. So, so check this out. So yes, you're right. So back to the helical bore, we're gonna go over here to parameters. And that's easy because we go to our linking, right? And now the top of the stock is 0.99. Thank you very much. That would have been bad. So now we bore a big hole in it. And then we come out, we cut that. It's not the best. I probably should have just kept it as 1/4 inch. We wouldn't have had that issue then. Is everybody good with this? The idea is to learn how the workflow of cam for this. And you're going to slowly start to use Mastercam starting next week. So, well, we started this week technically. But there's homework next week for it. Cool. So now we're going to go ahead and drill and then chamfer. Sound good? So to drill, I go back to tool paths. I'm going to pick drill. And I'm going to go pick my hole. This thing gets in your way. I just move it out of the way down here. But you pick the center of the hole. Don't accidentally pick the tangent edge. It will drill on the tangent edge. So we grab that. It's a 1/4 inch diameter. We hit check mark. It's a tool that we're going to set up. I think it's going to be tool 13. So create tool. We're going to grab drill. Next. It's 1/4 inch. Cutting length is definitely more than one. One will be fine. We're just going to go hit next. The diameter is what mattered. 13 is the cutting tool's number. It's going to run a 250 service speed. It's high-speed steel. And feed per tooth, it's going to be a 1 tooth because it's inch per rev on drills. And a 4 thou chip load. So 15.2, 16. Cool. We good on that? So we're going to do a 16 plunge as well and 500 retract. So when I hit finish, we've got our 1/4 inch drill. We're going to go to the holder. Doesn't matter. We're going to leave it in that holder. The stock does not matter. The cut parameters matter. What type of cycle does a drill do with G-code? They're called can cycles, right? So when I look in here, I've got all my can cycles. I got my bores, my taps, my peck drill. We're going to peck drill. We're going to peck drill 1/4 inch pecks. We're going to go through this part. Sound good? Cool. So that peck value will be 1/4 inch pecks, and it clears the chips. We haven't set the depth yet because the depth is underneath the linking parameters. So the retract is 1.1 absolute, right? Then the top of the stock is actually the top of the stock is 0.74 absolute. Right? Because it's down in there in the pocket. The depth, I want to go absolute 0, but would that drill through the part? No. So there's this button right here. Based off the 118-degree tooltip angle, I need to add the -0.75 to it. If I hit add to depth and hit check mark, now I drilled through the tip thanks to the trig. What do you think I do when I get this weird number like this? I'm going to round up 5 thou. So I'm going to go 0.80 thou. Makes sense? So it definitely pokes through. So that's going to adjust for the tip. The last thing we got to do is coolant and on check mark. It drills a hole right there, I promise. And it goes through the bottom. You see that? Oh, we haven't been simulating. We should do that. So we go back to the toolpath group. Does everybody see how there are check marks on them? If I don't click the entire toolpath group, it won't simulate everything at once because they're not checked. So it's only going to simulate what's checked. So now when I hit this verify button, it brings the block. Oh, now we're up to 6 minutes for this part. Woo! Jeez. We can go a lot faster, but we're not on this one. We're learning. So we'll press play. Wow, too fast. I know it cuts a little air on the bore. I'm not too worried. We can fix that later. Is everybody good on that? So now it's a really sharp part. So the last operation is going to be to chamfer the thing. So there is a chamfer, was it a chamfer drill even nowadays? There's a chamfer toolpath, isn't there? Yeah, back in my day, we didn't have that. We did it with contour. I'm still going to do it in contour because it's literally the same toolpath. It's just missing a bunch of stuff that contour has to make it easier. So we're going to do it in contour. Sound good? So I'm going to pick contour. Now, when I chamfer, check this out. I've got to do this one. I've got to do a split. This one right here. It's not called split. It's called edges. I pick the bottom because it's the real size of things. I work myself around. You good with that? Now, if I want to go ahead and chamfer outside and inside in this same tool path, does everybody see this button right here, in chain? You need to in the chain because it's its own chain and it puts a little green arrow on it. Now, I can go back to the inside, zoom in a little bit, and I work it around like this. Sound effects help. So when I hit check mark and I go back and I look at it, I've got two chains. One of them is in a bad situation though. Which one? Yeah. So they're underneath here. Do you see how there's this one or there's that one? That's the one I want to switch. So if I just hit change side, it changes sides of both. That's right. Hold on. It's the reverse then. So wait, that one goes to reverse. Yeah. Cool. Because change sides changes everything. Reverse will just reverse the one. I didn't remember that off the top of my head. Can you what? We're good? Cool. Now, so now the last tool, the 14. So we're going to go ahead and create tool. It's going to be a chamfer mill. You see that? Chamfer mills make the difference when you fill out this tip diameter correctly. So you got to look up the tip diameter out of your, where you buy it from. I think our Haas one was 25 thou or something, right? I'm going to put 35 thou just in case. It just offsets it a little bit more. Now, its overall diameter is 0.25. Actually, it's a small one. I'm good with that. You go with that? Its cutting length is not 3. Oops. Oh, that's a shoulder length. I got you. Cool. So now when I go to next, we're going to just go to 14. It's going to run a surface speed. We're trying to max it out here, 650. It's almost like 10,000 RPM, right? It's a 4 flute and it's going to run a 2 thou chip load. So I go up to 80. Sound good? 80, and then we'll do a 40 plunge for now. So when I hit finish, the key to the chamfer is right here. You make it say 2D chamfer and you got the chamfer toolpath. It's like, so like, just use contour. It's literally right up here. It becomes the 2D chamfer toolpath at that point. So it's 2D chamfer. Now you'll make a really big chamfer with their default values. So the bottom offset's just how much it offsets it. I'm just going to do 25 thou offset a little bit more. But the chamfer width, if I look at my drawing, is 10 thou, right? Everybody see that on their drawing tool? Now, the way chamfers work is they don't get depths of cut. So you turn off depths of cut. They get lead in and lead outs, so we'll leave those on there. Sound good? They don't get multiple passes, so we'll take that off. We'll unclick that. And the chamfer gets the same depth of the top of the part. So if I give it the same depth of the top of the part, it uses the trig and the tool to figure out the right size with that box. So when I hit check mark, so everybody see it rounded the tool around the outside and the inside of my part right there with some lead in and lead outs. So this part is almost done. It was only an hour and 20 minutes to program with me goofing around. So let's check it out. let's hit this button right here. Bloop. We'll press play. Goes kind of fast. There you go. Nice little chamfers. You see them on the part. What you see is what you're going to get. Usually. It doesn't turn yellow though. So what we've got, oh, I was going to show you something. Now I'm going to press save. Back here. Let's say you're like really into additive manufacturing and you were like, this is subtractive. I'm just taking it because it's required. So that could be you. You never know. But check this out. When it's all done, you can make 3D models from this thing. So if you go to verify, save stock as STL, I just saved my simulation that this cut out as an STL model, and I can go 3D print it and to check my operation out. Kind of cool. It's up to you. I'm not a big 3D printing fan. It's me. I like metal. They do make metal 3D printers, I know, but they're not quite there yet. When it's there, I'll switch. So I might be retired by then. So they do make. I'll show you the Meltio with the Haas and the 3D printer on the same machine. It's pretty cool. But that's gonna be a totally different thing, and I'm on a video recording, so I'm gonna keep going. So that's basically everything we needed to make this part. Right? We got all the tool paths. We simulated it. Now, what's the third component? Post-processor. So this is the only thing you can't do on your code. You have to come here. We're going to get it installed in lab 25. We're working on that. It'll be installed just in time when you need it. We have dongles for right now that'll work in the lab for you for it to work for you. Sound good? So what you're going to do, does everybody see this G1 code? Yeah? If everything's check marked, you hit the G1 button, it saves as a .nc file. Oh yeah, look at that. We've heard that before. So I hit check mark and it saves it in my Mastercam files, wherever they figured that out in your documents. You hit save and it brings up the code expert, which you don't have. And it leaves these really long file extensions because I have really long file extensions and it errors out the machine on me every time. So I delete that. And what's wrong with the program number? Just all zeros. We got to be able to fix that, right? We call this like 336. Cool. Now, look at this, T11M6, G0, G90, G54. Oh, it's got an A0. The machine's just going to fly over that, not worry about it. We have an A axis in the machine. It's just going to ignore that one. But look at that. You got your 3 startup lines, just like you learned, right? Look at it, rapids to above the part, that 1.1, that absolute. Turns on the coolant, then it feeds down to where the top of where the bottom of the cut is and feeds across, right? Or feeds down, then feeds across, then comes back up to the rapid position. You wrote code just like that. But it's way easier with the CAM system, I promise you. Now, with that, let's jump back to the PowerPoint. I'll repost it and I'll run one for you, or run one with you maybe in lecture or something tomorrow after the test review or something. At 3 o'clock, I don't do anything like other than ride home to get Spruce out of the house. So I'll run it probably right at the end of lecture tomorrow at 3. It'll be like a thing that you have to show up after a lecture to go see down in the lab if you want to see it. Sound good? So with that, I'm going to stop the recording for the actual Mastercam demo. And then we're going to continue on in lab with the other lab stuff. Cool. So pause, stop recording.